Today's video deals with presenting experimental data or graphing. When we do experiments, we collect vast amounts of data either through observations or making measurements. We organize that data in tables, and then we take the data from our tables and display it in a graph. If we look at a data table, there is certain information that must be required. The variable tells what information we are recording. So if you take a look at this data table, the first variable is time. The second variable is plant height. And those are the things that we are measuring and recording. The unit tells how we're going to measure that variable. So for time, our unit is days. That's important because if I didn't have days here, and I just had time and numbers, I wouldn't know if that's days, seconds, minutes, weeks. So it's important that you always include the unit. You put the unit in the header, then you don't have to put it next to each number in the column. For plant height, our second variable, our unit is centimeters. Again, that's important because if I didn't have the unit, I wouldn't know these numbers are centimeters, inches, miles. So including your variables and units is always important. We always write it with the variable first and the unit in parentheses. So the data table, in addition to variables and units, is also going to contain a descriptive title. Someone should be able to read the title of your data table and know exactly what your experiment is. So in this case, water temperature at various depths. I know that I am measuring the temperature of water at various depths. A graph is a good way to visualize the data from a data table. It's a way to create a picture of data. Instead of just analyzing the numbers from your table, it's a little bit easier to see a picture. It also helps us see relationships between the variables. There's three types of graphs that we will use in earth science: line graphs, bar graphs, and pie graphs. So starting with the line graph, notice that all of the information that's in the data table is transferred to the graph. We have the title, we have our variables and units, we've got temperatures in degrees Celsius here, we have frog croaks in 1 minute intervals here. Notice that you can look and see the numbers and see that yes, frog croaks increase per minute with an increase in temperature, but if you look at the graph, you can see how fast it increases. And notice that at the higher temperatures, we really see a quick increase. With a graph, you can also estimate. If I wanted to know how many frog croaks per minute there were at 33 degrees, I could come on my graph over to 33 and go up and estimate about what that would be. So when we do experiments, you'll always be controlling one variable to see how it affects another. So a line graph allows us to see this relationship between those two variables. Usually, we'll see how a certain variable changes over time. If that's the case, time is always going to go on the x-axis. In this experiment, there are two variables, time and temperature. Time is a variable that's being manipulated because that's what we're changing. As time passes, we're recording measurements of temperature. We can break this graph down. If you're describing what happens, you would say from A to B, when time increases, temperature increases. From B to C, there is no change in temperature, or the temperature stays the same. C to D, we see an increase. D to E, once again, is constant. E to F, we see an increase. It's important that when you describe graphs, that you can look at the general trend, like I know that there's a general increase over time, but to break it down section by section and what is happening in each time frame is also important. Bar graphs are another way to show relationships between variables. If you're not looking for patterns over time, or if one of your variables is not numerical, this is when a bar graph would be appropriate. So for example, I have deaths per year, so that's numerical on my y-axis, but my data that goes on my x-axis is not numerical. They are preventable causes of deaths. So you can see here, I can easily compare the different types or the different causes of death with their numbers. A pie graph is another way to display data. This only works if you have variables that add up to 100%. So each slice represents a percentage. So in this example, we're looking at energy consumption in the US. So you can see that petroleum is the largest percentage at 41%, so it's the largest piece of the pie. Again, another great way to visualize data